So for 12.5, number 9, they have a bag contains 7 light bulbs, all the same size and equally likely to be selected. Each light bulb is a different brand. If you select 3 light bulbs at random, determine how many points will be in the sample space with replacement. So we're selecting 3 light bulbs. We have 7 possibilities for the first light bulb we pick, and then part A is with replacement, so we're putting the light bulb back, so there's still 7 possibilities for the second light bulb, and then we put that back, so there's still 7 possibilities for the third. So 7 times 7 times 7 gives me, 7 times 7 times 7 gives me 343. Now for part B, we're not replacing the light bulbs, so there's 7 possibilities for the first pick, and when we take that light bulb out, 6 possibilities for the next, 5 possibilities for the next. So 7 times 6 times 5 is 210 possibilities. Thank goodness we don't have to draw a tree for that. So for 13, box contains 3 cards, a sun, a question mark, and an apple. 2 cards are to be selected at random with replacement. Determine the number of points in the sample space. So selecting 3 cards, 3 possibilities for the first one with replacement, so 3 and 3. So there's 27 possibilities total. And they want us to construct a tree diagram. So if we say we could get sun, then question mark, then apple, and then for our second pick we could get a sun, question mark, or apple, a sun, a question mark, or an apple, a sun, a question mark, or an apple, and then sun, question mark, apple, sun, question mark, apple, sun, question mark, apple. I see what you mean now by referring to the book. So let's refer to the books. And, oh, wait a second. 2 cards are being selected at random. Ha! 2. So check this out. No more third possibility. So 3 times 3, 9 possibilities. I thought I remember the other trees being smaller. And we don't have this third column there. So this is just selecting 2. So if we write all the possibilities, we have sun and sun, sun and question, sun and apple, question mark sun, question mark, answer, apple, apple sun, apple question, apple apple. So those are 1, 2, 3, 4, 5, 6, 7, 8, 9 possibilities. And then they ask us questions. 2 apples are selected. So 2 apples are selected, that's just this last possibility out of the 9 total. So 1 possibility we want out of 9 total. And for part D, they want a sun and then a question mark. So this is the only one with a sun and then a question mark. So again, 1 possibility that we want out of 9 total. And for part E, at least 1 apple. So he has no apples, he has no apples, he has an apple, he has an apple, he does, he does, he does. So I have 1, 2, 3, 4, 5 possibilities I want out of 9 total. So that's that one. For 17, let's see. They select 1 color for the walls and 1 color for the trim. So the walls, they could choose Sable, Java, chocolate, is their choice, right? And for the trim, they could choose alabaster, white, or oyster. So alabaster, white, or oyster, alabaster, white, or oyster. And I should have done this part first, but part A, how many are in the sample space? 3 possibilities for our first pick, 3 possibilities for our second, for 9 possibilities total. So here's our tree in part B, and we see all 1, 2, 3, 4, 5, 6, 7, 8, 9 possibilities. So I've got sable and alabaster, whatever these are, just list them out. And now we can answer any question they want. The probability that they select Java, so how many of these have Java in them? This guy, this guy, this guy, that's it. So just 3 out of the 9, so 1/3. And for part D, Java and Oyster, so this one's the only one with Java and Oyster, so just 1 out of the 9. And paints other than Java, so no Java. So basically, excluding these ones with Java, we have 6 that we want out of 9 total, 2/3. And that's that. C21. So for 21, 3 different people are to be selected at random, and each will be given 1 gift card. There's 1 card from Home Depot, Best Buy, and Red Lobster. Alright, so there's 3 people who get to select something. The first guy gets his choice from all 3 of them. The next guy has to pick from the remaining 2. And the last guy's stuck with whatever's left. So 3 possibilities for your first guy, 2 possibilities for your second, and 1 possibility for the third. Gives you 6 possibilities total for part A. And so that's not too bad. We'll draw a sample space. So your first person could pick Home Depot, Best Buy, or Red Lobster. Your second person, if this guy picked Home Depot, your next guy has a choice of Best Buy or Red Lobster. And then this guy, if he picked Best Buy first, he would have a possibility of Home Depot or Red Lobster. And if the first guy picked Red Lobster, then the third guy would have to choose between Home Depot and Best Buy, leaving the third guy with little choice but to choose the remaining one. So Red Lobster waits for him. Home Depot, Red Lobster, Best Buy, Home Depot, Red Lobster, Best Buy, Red Lobster, Home Depot, Red Lobster, Home Depot, Best Buy, Red Lobster, Best Buy, Home Depot. Okay, joy. They want probabilities that, so I guess I should write out the whole tree like I was just saying. So HBR, HRB, BHR, BRH, RHB, RBH. Alright, so they want the probability that a Best Buy card is selected first. So the only ones here with Best Buy first are those. So 2 possibilities that we want out of the 6 total. So 2 out of 6 is a third. For part D, the probability that a Home Depot card is selected first and a Red Lobster card is selected last. So Home Depot first, Red Lobster last. That's the only one that we want. So just 1 out of 6. 3 cards are selected in this order: Best Buy, then Red Lobster, then Home Depot. So Best Buy, Red Lobster, Home Depot, just this one out of the 6 possible. And that's